Hello students, how are you? Good morning to all. I hope you are doing good. So how's everybody? Student of JNV Ramnagar and JNV. So firstly confirm that screen is visible to you and I'm audible to you. Then we will start the lecture, okay? Got it. So how are you guys? Having fun? Today is Sunday. Okay. So you are from JNV and I'm welcome. Welcome to all that belongs to JNV and I am very fine. Okay. I am totally fine. Thank you for asking. Student of JNV Ramnagar and student of JNV Yanam. So, in the last session on Saturday, we have discussed some of the problem related to wave, and I have said to you that some of the problem we are going to discuss in the next session, that is today. The concept and the formula will be same. Means the question that we are going to solve today is based on the same concept that we have did in the previous class. So the revision will be same. There is no needed to add extra formula or extra concept in that. Okay. In the next weekend, if there will be class, then we will start with the standing wave because till then we are able to complete the organ pipe or the concept of standing wave that I have already conveyed to you in the regular classes. But till then we are be able to conquer the questions related to the organ pipe, fundamental frequency and all. Okay. So today there is no change in concept or formula, the only change in the questions. But the level of question today is pretty good. Okay. In the beginning, the question that you will face, these are the questions that I like very much, and they are very conceptual, concept-based question. Okay. Now to start with the revision, the student of JNV ENM. So we have did with what is wave. Start with this why. What is wave? So wave is a disturbance of energy and momentum which travels from one place to another place with the help of medium and without help of medium. If it is taking the help of medium, then it is a mechanical wave. If it is not taking the help of medium, then it is a non-mechanical wave. Okay. What is a mechanical wave? That requires a medium. Okay. To propagate, like water pulses. When you drop some stone in the pond, the water ripples that form on the surface are the mechanical waves because they require a medium to travel. Okay. But if you talk about the non-mechanical wave, this could be, this does not require any medium to travel. One myth I will let you clear with you, that there are two types of wave also in the classification based on the wave motion and particle motion. So we have two types of wave based on that. First is the longitudinal wave, second is the transverse wave. So we always have a myth in our mind that the wave that is transverse is belong to the non-mechanical category because the EM wave is a transverse wave. In EM wave, the propagation of electric and magnetic field is perpendicular to the wave motion. But it is not true. I'm not saying that it is incorrect, but it is partially correct. So you need to correct yourself that transverse wave can be formed with the help of a medium also. Okay, so there is no restriction in that. When we form a wave using a rope, that wave is also a transverse wave. When the ripples has been formed on the water surface, that wave also a transverse wave, because in that wave particle is oscillating about their mean position and wave disturbance is traveling in another direction. Got it? So it is not a rigid concept that a transverse wave should be a non-mechanical. It could be both mechanical and non-mechanical. Okay. Now, so if we talk about the traveling wave function, so whatever wave you are dealing with is in the form of y is equals to f of ax plus bt. This is the wave function. This here, which is denoted by this line, this here is the wave function. F is equals to y is equals to f of ax plus minus bt. So anything when you see of this form will be a wave function. Now, this is the general equation of wave. So if any function, like I will give you a function like this, y is equals to 2x square plus 2t square. These types of function I have given you, and I am asking you that classify this function as a wave function. Check it. Is this represents a wave or not? So what you are going to do, firstly, you will going to apply this equation, which is del 2y by del t square equals to minus v. V here is the wave velocity. Okay. V here is the wave velocity into del 2y by del x square. Now, I have already told you in the regular class that how to differentiate a function with partial differentiation technique. So if you are differentiating with respect to time, then all the other variable will remain constant in that expression. So suppose in this expression also y only, y is equals to 2x square, 2x square plus 2t square. If I differentiate this function with respect to t partially, this represents a partial differentiation symbol, which is del. Okay. So for that, this x will be treated as a constant quantity. So the differentiation of any constant will become 0 plus it will become 40. T square का differentiation is 2. Now same way में if you will d del y by del x, then the time function, the time variable will be constant, and this will be a variable. It will become 4x. Got it? Now, so to check whether a function is a wave function or not, that function must satisfy this equation. Okay. Now we know that every particle is doing SHM, sorry, doing oscillation in the wave motion, but that oscillatory motion, if that oscillatory motion is SHM, then that particular wave is termed as simple harmonic progressive wave. So what do you need to remember about the simple harmonic progressive wave? If you encounter with a simple harmonic progressive wave, which means that each and every particle in simple harmonic progressive wave is doing SHM about their mean position. Got it? It could be linear and it could be in this way, to and fro, and it could be to and fro in perpendicular direction. So it is easier for us to understand in the perpendicular way on the transverse way. So we will conclude this. So general equation here is y is equals to a sine omega t plus minus kx plus phi naught. where omega is 2 pi f, and omega itself is angular frequency, f is the linear frequency, k here is the wave number, 2 pi by lambda, phi naught is the initial phase. Okay, and this whole term omega t plus minus kx plus phi naught is phase. And what is a phase? Phase is the initial state. Oh, sorry, phase is the status at any instant and at any position of the wave. किस वक्त किस पोजीशन पे वेव कहाँ है, it will be only determined with the help of this phase. Okay, phase को you can keep in your mind like the location tracker. Okay, when police finding something, so what they will do, they will trace the phone calls and get to know the exact location of that. Okay, so same way में, if we want to know the exact location of a wave at particular time, so the phase will be that location tracker. Or you can relate the phase with police. P for police. And what does police do? Police track the phone to track the criminal. The same way में phase will track the wave to get the values of wave displacement. Okay. So P for police, P for phase. Now V is equals to omega by k is the wave velocity. The coefficient of time divided by coefficient of what? X. Got it? Now, if I talk about the speed of transverse wave in string, so it will be given by V is equals to square root of T upon mu. T is the tension, mu is the linear mass density. Specifically, speed of transverse wave in any material or solid material, it depends on the elastic property of that material and the inertial properties of that material. More will be the inertia, more will be difficult to move that particular object, that particular material. So that is why it depends on mu, which is the inertial factor inversely. So V is directly proportional to 1 by mu. And it depends on the elasticity directly. An elasticity factor is given by the tension in that string. Okay. More elastic will be the string, more its tendency to come back to the original position. And what is happening in the transverse wave? The particle is displacing from the mean position. It is more important to come back. Now the speed of longitudinal wave in gas is given by gamma p upon rho. Same way में it will also depend on the initial property, the inertia property and the elastic property. Got it? Now this question as a masterpiece question I will say. Now try to solve this question. I'm giving you 2 to 3 minutes to just think about this question and to solve it. Okay. What is this question? What has been asked in this question? How to approach these types of question? Just think about it. Okay. Let me read it first. That a uniform string of length L is suspended from a point on the ceiling. A small wave pulse is now introduced at its lowest end and it start moving up towards the ceiling. Now, first that you have to find and what will be the speed of the wave pulse, and when it has moved up a distance x. So when the wave at a distance x, what is the speed of the wave? Okay. Second thing is that how much time does this wave pulse taking to reach the ceiling? This is also you need to calculate. A first pointer in this question is, if I talk about, the very first pointer is given in the first line only. uniform string. This string is uniform, which means the linear mass density, mass per unit length, is also constant in this. Got it? And it has a length L. Now, what will happen if I give you an idea? Suppose this is the ceiling that we have, and this is the rope or string. Okay. Now, so when we give it a pulse to this, suppose we have given a pulse. So that pulse will look like this, and this pulse will travel in the upward direction. Got it? Now, as the wave pulse, because in this pulse, these elements are being stretched with a tension T. There will be stretching in the string. Okay. Now, if I talk about the lower end, is this anything downside? No. So here, what will be the amount of tension? If there is no wave pulse, there is no amount of tension. Only the weight of the string is valuable then. But when the wave pulse is created, there must be a tension due to the shape of the wave. This one, the string get stretched somehow when we generate a pulse in it. I have told you that if this is a string and when we create a pulse in it, the length is somehow greater, which means the string is now stretched and it has tension. Okay. So if the wave creating a tension in the string, so when it moves up, suppose let's say this is here, now the wave is here. So this much portion, if I separate it with this, so in between these the tension is acting. If the wave is here, in between these the tension will acting. Now, I have told you in the mechanical properties of solid that in a wire or in a rope, the tension will depends on position. If you want to calculate the tension developed at this part, so only the portion that is below this part will applying a tension due to its weight. When you talk about this, so the portion that is lower side of it will be responsible for the tension in the upper side. So as the wave is creating tension in this string, what is happening? The wave is moving up. Wave is moving up, which means the point of tension is being changing. So when wave is here, this much portion is applying tension due to its weight. When wave is here, this much portion of the wave is applying tension. So here the tension is variable. Tension is a function of position where the wave pulse is. Got it? I hope you got it. If anyone has any kind of doubt, they can. Now, the very first question that has been asked, that what will be the speed of the wave pulse when it has moved up a distance x. So let's say here it is at distance x and the speed of the wave pulse is v. Now we know that We know that speed of wave, transverse wave specifically, is given by T by mu in rope or stream. How many of you are aware about this formula? We have just talked about it, na? Okay. So this is simple. यहाँ तक सबको clear है, I think. Okay. If anyone has any kind of doubt, you can ask right now. You can unmute yourself. You can comment in the chat box, whichever the way suits you. Okay. Now, now what is the tension at this place? What is the tension? If I just separate this portion with this, so in this portion, the tension will be developed by this portion in the downside. And this portion has some weight, let's say mass m dash into g. This is the weight. And due to this weight, there will be the development of tension in the string. Okay. Now, m dash here we can say, because we know that this is a uniform string. So the mass per unit length, which is the linear mass density, will be a constant quantity. So for this, we can say the mass m dash is given by mu, mass per unit length, multiplied by x. This is the mass by mass per unit length. And up to how much length we would want to know the mass? Up to length x. So m dash here is given by x mu. Okay. Now, in this portion, which has a mass m dash g, it is acting downward. Due to this portion, the tension will be developed in the upper portion because it is stretching it down. Okay. So in the counter of it, this rope will apply a tension to this part. So there will be a development of tension. So we can also say that tension here is equals to m dash into g, and which is nothing but a mu x into g. Got it? Now, if we put the value of tension in this expression, so we have as mu xg divided by mu, so we can cancel it out, equals to square root of x into g. This is equation number 1 and the answer to the first question. So this is the speed or velocity of the wave when it has moved up to a distance x. Got it? Any kind of doubt, guys? Student of JNV Ramnagar and JNV Yanam. Any kind of doubt in this question? Is this clear to you to this point? JNV Kolhapur. Please be responsive, na? And let me know if you got it or not. Okay. Now, now the second portion is that. Okay. Got it. Thank you. So now the second portion of the question says that how much time does this wave pulse take to reach the ceiling? Now, what is the length up to ceiling? Is capital L. The length of the string is capital L here. Now, what we can do? We can take this equation v is equals to square root of xg. Now, dx by dt, I can write it root x into root g, separate. We have separated it. Now, dx by dt equals to root x into root g. So we can say dx upon root x equals to root g dt. Now at t is equals to 0, the length will be 0 because the wave pulse started at the lowest point. When, let's say, time is t, the length it has covered is capital L. Okay. Now if you integrate it, so you must remember the direct formula for integration of root x and differentiation of root x also. So 1 upon root x is nothing but 2 root x. Okay. But if we talk about the differentiation of root x, it is given by minus 1 upon 2 root x. Got it? But differentiation of 1 upon root x is given by minus 1 by 2 x raised to the power minus 3 by 2. Okay. Now, so here we have differentiation of root x. So we can write it as 2 root x multiply, limit are 0 to L, and here root g is constant. So integration 0 to 2 dt will become t. Now we put the limit in this, it will become root 2 root L divided by root g. So we can say it is 2 upon L upon g. So this much time the string, the rope, or the wave will take to reach the upper end of the rope. So any doubt in this? Any kind of doubt in this question? Tell me, each and every one of you. So if I just want to ask that find the acceleration of the wave. Got it. So try to find out the acceleration of the wave. Find out the acceleration. And I want answer from all of you in the chat box. Okay. Let's say who will do this. Is JNV Yanam student are more superior than JNV Ramnagar student, or vice versa? Or JNV Kolhapur student will lead the path? Let's say who will do this. Find the acceleration. This is the competition. This is the war. Let's say who will win this war. What is the acceleration? This is the expression of velocity, root x by g. Try to find out the what? Acceleration. What is the acceleration? Any one of you? Anyone find out the answer? Come on, guys. I don't want you to lose. Okay. So JNV Ramnagar student, JNV Kolhapur student, JNV Yanam student. No one of you are able to find out the acceleration. It's so simple. Okay, so I'll do it. That V is equals to root x into G, root xg. Okay. Now, to find out the acceleration, we have to differentiate it with respect to time. What is the differentiation? Now, root g is a constant quantity, so it will be d by dt of root x. Now, what is the differentiation of root x? I have already told you. It is, sorry, it is not minus, it is plus 1 upon 2 root x. Okay, because d by dx x raised to the power n is n x raised to the power n minus 1. So here root x means x raised to the power 1 by 2. So it is 1 by 2 x raised to the power minus 1 by 2 into dx by dt. That's how we are going to do. Okay. Now root g 1 upon 2 root x dx by dt is what? Dx by dt is the velocity itself, which has a value of root x into g. Now root x and root x will cancel out, and this will become root g into g, root g divided by 2 g by 2 meter per second square. This, how, look how simple is this. Okay. Now, if I ask you one more question in this, should I ask you? Yeah, I definitely ask you. Ki, if this whole setup, if this whole setup is moving upward with an acceleration a, this ceiling and with this rope, this all are moving with an acceleration a. Let's say this setup we have set in the elevator, and the elevator is going up with an acceleration a. Now what will be the effect in the time period of that? Firstly, you will tell me that is there any effect or not? The time period to reach that the wave has taken to reach the end, upper end of the string, will it change or not? If the whole system is moving up with acceleration a, if it is going to change or not? Any one of you? Student of JNV Ramnagar? JNV Yanam student? Any one of you? If the whole setup is moving with acceleration a upward direction, will the time period change or not? Only yes and no is being required. Try to answer it. Okay. Yes and no only. So JNV Yanam student is saying that yes, sir. Okay. So I am writing two options here. You need to choose one of them. If the whole setup is moving up, the new time period T dash will be 2 root L upon G minus A or G plus A. So which one is correct? This is option 1, this is option 2. Why are you not answering the student of JNV Ramnagar? You are very responsible from the beginning. To tell me, option 2 you are saying. Okay. And what about you, JNV Ramnagar student? Is any kind of issue you are facing with the network and connectivity? Please let me know if it is, because I am expecting a answer from you guys also. Okay. It's very wonderful to see that JNV Yanam student, one of the JNV Yanam student has answered, and it has answered is correctly, because when the lift or whatever the system is moving up with an acceleration A, there is a downward acceleration G also. But we are sitting in this arrangement, so the effective acceleration will be A1 minus A2. Since these are in opposite direction, so they will add up. So it will become A plus G or G plus A. So very good, brilliant answer by student of JNV Yanam. So student of JNV Yanam win the race, and I congratulate to them. Okay. Now move on to the next question. This one. This is also a very interesting question and very conceptual question. A wave pulse start propagating in the positive x direction along a non-uniform wire. Now this time this wire is not uniform. Okay, which means the linear mass density will change here, and which is also given in the question. Along a non-uniform wire of length L, capital L, with mass per unit length is given by mu is equals to m naught plus alpha x, which means as the length changes, the mass of the rope will change under a tension of 100 Newton. So this string is stretched under a tension of 100 Newton. The tension applied is same. Okay, whatever the cross section you will take, whatever the section you will take of the string, the tension will be same, 100 Newton. Now find the time taken by the pulse to travel from the lighter end at x is equals to 0 to heavier end, where m naught and alpha are the constant. Let me solve this question firstly. So here we are given that this is a rope of length capital L, and the linear mass density is varying as m naught plus alpha x. Okay, and the tension applied in the string or in the rope is T, and this T is equals to 100 Newton. Got it? Now we know that velocity in a string is given by tension upon mu. Simple question. Tension is given 100 Newton. Mu is the expression is given to you m naught plus alpha x. Okay. Again, in the previous question to find out the time, what we have did? We have just mentioned it like this: dx by dt equals to square root of 100 divided by m naught plus alpha x. Got it? Now it will become root m naught plus alpha x dx equals to 10 dt. Now we just integrate it from 0 to t, 0 to L. Okay. Now this is a this complete setup, you can say the square root of capital X, and capital X is equals to m naught plus alpha x. Okay, so differentiation of such type of integration of such type of expression is given by integration of root a plus bx dx is given by what? 1 upon b. Whatever the coefficient written in the multiplication of x, you need to divide with that 1 upon b. If it is minus, so you need to divide it by minus b. Okay. Into this whole function, you need to treat it as root x. So integration of root x, I have told you, x raised to the power 1 by 2, and integration of this will become x raised to the power 1 by 2 plus 1 divided by 1 by 2 plus 1. Okay, so we can write it as a plus bx. Now remove this square root, a plus bx raised to the power 3 by 2 multiplied divided by 3 by. The same thing we need to do here. So this expression will lead you 1 upon alpha m naught plus alpha x raised to the power, just a second, m naught plus alpha x raised to the power 3 by 2, 0 to L, and that 3 by 2 will come upside, so will become 2 by 3. Okay, equals to 10 into t. This expression will lead you what? 1 upon alpha, or you can take this 2 by 3 also common, 2 by 3 alpha, put the limit. So when you put L, it will become m naught into alpha L plus, sorry, minus. When you put 0, so alpha x will become 0. So it is only m naught equals to 10 into t. So time here you will take 2 5s are 10. Time will be 1 upon 15 alpha square root of m naught, and this is not square root actually, it is raised to the power 3 by 2. Okay, m naught plus alpha L raised to the power 3 by 2 minus m naught raised to the power 3 by 2. What you can do, you can take this m naught common. The time will become m naught raised to the power 3 by 2 divided by 15 alpha, and this will become 1 plus alpha L upon m naught into 3 by 2 minus 1. Okay. Now, if you apply the binomial expansion for smaller values, so exactly this is the answer. But for the approximation purpose, if we apply the binomial theorem in this, so this we can say this is the answer here. But to further extend it to the more suitable, more relatable value, so we can say that applying binomial theorem. So if alpha is too small, so we can apply that m naught 3 by 2 divided by 15 alpha 1 plus 3 by 2 alpha L upon m naught, and neglecting the higher power, minus 1 and 1 will cancel out, 3 5s are 15. So this time period will lead you to what? M naught raised to the power 3 by 2 alpha L divided by 5 alpha into, sorry, 5 to the 10 alpha, 5 to the 10 alpha m naught You can take this m naught upside, so it will become t equals to, the power will be minus 1 here. 3 minus 2 will become 1 by 2. So this is, and alpha is also cancelled out. So this time period will become root m naught L by 10. Okay, so I hope you got this question and this answer also. Okay, this seems to be a lengthy question, but it is a very simple question. Just know the concept of it. Okay. Now, if you have any kind of doubt in this question, you can ask. Otherwise, we will move to the next question. Now, the speed of sound in air at NTP is 320 meter per second. If the pressure is increased to 9 times the atmospheric pressure, the speed of the sound in the air will be. Tell me. This is very easy question, guys. So take your 1 minute to solve this question and let me know the answer. Exact answer. Okay. I have told you the formula, the speed of sound in gases, and you need to use the Laplace correction, the correct formula, not the wrong one. So your 1 minute is filling up. Hurry up, guys. Hurry up. Student of JNV, Ramnagar, JNV, Janam, Kolhapur, and other students also. Answer to this question. Your time is going up. Now start counting. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Time up, guys. So if any one of you have solved it, comment the answer and now focus on the solution. Okay. Now we know that speed of sound in air is given by V is equals to gamma P upon rho. Okay, gamma P upon rho. So if the pressure is changing, it is nothing said about the gamma, nothing said about the density. So this all we can take constant. We can say that V1 is equals to gamma P1 upon rho. Density is not changing. V2 is equals to gamma P2 upon rho. Okay. Now take the ratio V1 by V2. It will become what? Root P1 by P2, because gamma and P will cancel out. Now it is given in the question if the pressure is increased 9 times, which means the final pressure is 9 times of P1. What is the effect on the velocity? Initially the velocity is 320. V2 is equals to 1 upon root 9. 1 upon root 9 is 1 upon 3. So V2 will become 3 into 320, which is 0.6 meter per second. How simple is this? Okay. I hope you got this answer. Anyone, any kind of doubt, you can ask. Okay. Now this one. And after this question, we will wrap it up. Now, This is an important kind of question, and you can expect it in the upcoming exam of J in NEET. Now, the two strings A and B made of same materials are stressed by same tension. स्ट्रिंग की बात हो गई है. स्पीड ऑफ द स्ट्रिंग लिखो सबसे पहले, टी अपॉन. If any one of you have paid attention to the regular class, I have already told you a formula, modification of this formula. So JNV Ramnagar student is saying that answer is 1 by 2. Let's see. So if the length of the string is L, area of cross section is A, and mass of the string is M, we can say mu is equals to M upon L. Okay. Now mu is equals to M ko we can write what? Density into area into length. Density into volume is mass upon length. So mu we can replace with density into area. So same we are going with VA is equals to TA, tension in string A, mu A. So we can write it as TA upon rho of A, area of A. Now, if the material is same, density will be same. Tension is, if they are stressed by the same tension, so TA is equals to TB. VB we can write TB upon rho B AB. Okay. Now take the ratio. So VA by VB will become TA by TB into rho B AB divided by rho A of A. We have just divided, okay? There is no rocket science I'm using in it. So see the same material, rho A and rho AB will be same. If the tension is same, T and TB will same. So only the remaining thing is area. Now, the radius of the string of A is double the radius of B. You can say that radius of A is 2 times of radius of B. So area of B we can say, because this string you can consider to be a circular string like a cylinder, and this it has an area of cross section pi RA square. Sorry, ऊपर में B and pi RA square. Now put the value. RA is equals to 2RB. Pi and pi will cancel out. RB square is equals to 4RA square. RB square. This RB and RB will cancel out. So VA upon VB is equals to 1 by 2. This is the required answer. V and VB. So very good student of JNV Ramnagar. Congratulations, you have nailed it. So this is it for today, guys. We will meet you in the regular classes and complete this chapter of wave mechanics. Now, till now, if anyone has any kind of doubt, you can ask. Otherwise, the lecture is being over. Thank you so much for being attentive. Take care of yourself. Bye bye.